Hi, welcome to section 3.1. This is factoring polynomial expressions. First, we're going to talk about what are polynomials. A polynomial is an expression of finite length constructed from variables and constants using only the operations of addition, subtraction, multiplication, and non-negative integer exponents. And that part's going to be really important. So if we look here, now these might not look like polynomials, but they're actually just a special type of polynomial called a monomial. So in these are the following expressions, polynomials and y. 6x to the minus 2. We can say, no, this is not a polynomial because remember, it must have a non-negative integer exponent. And here we have this negative 2. The next one here, 1 over x. Well, we can rewrite this as x to the minus 1. And again, we have that negative 1 exponent. So therefore, no, this is not a polynomial. The next one we have square root x. Well, we can rewrite that as x to the 1/2. And again, this is a non-negative integer exponent. We have 1/2, which is not a integer. The last one we have 4x squared, which we could say, yes, is a polynomial because it has a constant and positive integer exponent. So, moving on, a typical polynomial will have many different terms. It will also have, usually at the end, a constant term. Any term that doesn't have a variable is called a constant. And these numbers in front of our variables being things such as x or y. These are called our coefficients. So let's do a couple examples. A lot of this is going to be review from Math 10. So factor the following binomials and trinomials and verify your answers. So if you remember from Math 10, we factor any polynomial by first looking at the first coefficient, which in this case is 1. So we know we're going to have x and x. And we look at our constant term, which is minus 21. So here we can have 21 times 1 or 7 times 3. So one of these pairs is going to go here. So in this case, we want two numbers which are going to multiply together to give us this number and add together to give us this number. So there's no way to make 21 and 1 add together to equal -4. So we're going to choose 7 and 3. And in this case, we need a -4. So we're going to make that 7 negative. And we can check that by just cross multiplying. So x multiplied by 3 gives us 3x. X multiplied by -7 is minus 7x. If we add those together, we get minus 4x, which is the same as theirs. So our first factor is this, and our second factor is this. So our final answer is x minus 7, x plus 3. Moving on, we have another similar one, but what you'll notice differently is this one has a 3 instead of a 1. So we could do it by doing the same method over here. But what you could notice is we have a 3, 6, 24. We actually have a greatest common factor of 3. So we can just remove the 3, leaving us with a squared minus 2a minus 8. And we're just going to factor this the same way we did over here. So a, and our factors of 8, we can have 8 times 1, or 4 times 2. Two numbers which can add together to give us -2. 8 times 1 is going to be no good, so we will choose 4 and 2. We'll put a negative here because we have a -2, so -4a plus 2a is -2. There's our first factor. there is our second factor. And that is done. So what you'll notice about this example, example 3, is this follows one of the special cases from Math 10. And it is called a difference of squares. And if you remember, a difference of squares is a squared minus b squared is going to be equal to a plus b and a minus b. So in this case, we have our a squared is actually our x squared minus the square root of 64, 8 squared. So we have our a squared minus b squared. So the answer to this will be a minus b and a plus b. And number 4, we're just going to do the exact same method as we did with the first one. We'll just do this one very quickly. X and x. Again, this could be 1.2 times 1. It could be 0.6 times 2. So we're going to go with 2, 0.6. We'll make that negative, which means we're going to get 2x minus 0.6x is equal to 1.4x. And we notice they're the same, so our two factors are x plus 2 and x minus 0.6. Now this next one is pretty tricky. It looks quite difficult, but we're just going to make it a little simpler. So if you notice, we have 3x minus 4 here and 3x minus 4 here. What we could do is we could say, let's let the letter a replace all of that inside. So let's let a equal 3x minus 4. That way, we can just simplify this to 6a squared minus 21a plus 15. And if you notice, this looks very similar to the other ones. We can also remove a GCF of 3, and that will get us 2a squared minus 7a plus 5. And we can factor this as normal, which will give us 3, 2a minus 5, and a minus 1 as our factors. Now all we have to do is take that a and put it back inside, which will give us 3 times by 2. Our a, remember, is 3x minus 4 minus 5, and 3x minus 4 minus 1. Now we can just simplify that. So 2 times 3x gives us 6x. 2 times negative 4 is minus 8 minus 5. And 3x minus 4 minus 1 is 3x minus 5. We can simplify further. 6x minus 8 minus 5 is the same as 6x minus 13. And 3x minus 5. And we are done. And for the next one, if you notice, we have the a squared minus b squared. This is another difference of squares. And what we can do is we can just take out a GCF first, greatest common factor. If you notice here, a greatest common factor we can take out is 1 over 12. That'll give us 1 over 12. We can take that out, giving us 16x squared minus y squared. Again, this is a difference of squares. A squared minus b squared. So we can just say this is equal to 1 over 12 4x squared minus y squared. So we can say 1 over 12 4x minus y and 4x plus y. There we go. And that is section 3.1, factoring polynomial expressions.